So this is mx. But anyway, you can try to solve by this method, but we still use the traditional way method. We do two parts. Okay? We solve this problem by two parts. So first thing, from this equation we solve the Gaussian equation is minus EI W double prime and minus N0W is equal to R1x minus P x minus A. Okay, this is my governing equation for this method. So first case for x smaller than a. For x smaller than a. So my governing equation is minus EI double prime minus N0 W equal to R1x, and R1 is L minus A P x. Okay, so this is a second order constant coefficient non-homogeneous equation. Or I transform to W double prime plus N0 W equal to A minus L over L Px. Okay, and divide by EI. I can change to we have W double prime plus N0 over EI. W equal to A minus L over L Px over EI. Right? And I define this is a lambda square. So lambda square equal to N0 divided by EI. Okay. Then I try W as exponential lambda x. So W prime is equal lambda x, and W double prime is lambda square E lambda x. So I have the eigenvalue problem will be lambda square. No. It's alpha, right? Alpha. So alpha square plus lambda square equal to 0 for homogeneous solution. So my alpha is plus or minus lambda. Okay. So I have a homogeneous solution as A sine lambda x plus B cosine lambda x. It's my homogeneous solution. Okay. Then the particular solution So we assume it looks like from the polynomial here is x here. So we try is look like cx plus d. Okay, 6 plus d. And the WP prime equal to c. WP double prime equal to 0. So we put this equation, we have N0 over EI. W is equal to CX plus D. And that will be equal to the P A minus L over L EI X, right? So from here, I can find N0 C EI equal to P A minus L over EI L, right? And D equal to 0. And so C equal to what? P A minus L over N0 L. Right. So my total solution is equal to homogeneous plus particular solution will be A sine lambda x plus B cosine lambda x plus C P A minus L over N0 LX. So this is my solution. For X is locating inside here, I call this solution 1 for the diffraction curve 1. Okay. Then for the second case, when X is locating larger than A. So second part, for X larger than A, my governing equation, X smaller than L, larger than A. Okay, then my governing equation become EI W double prime plus N0 W and equal to, here we have A minus L over L P X plus P times X minus A. Okay. So my non-homogeneous term become this thing, or we say, and we also can find a particular solution if assume it's EX plus F, and you can find E is equal to A over L P over N0 and F as P over A over N0. All right? So combined with the homogeneous solution again, you can get another part. So that means for this case, I have a P loading. This is a A, and this is a roller, right? For N0. So in the first thing, this is a W1, something like this. Okay, and from this part, I can get a second solution for X in this zone. And that will be have a equation something like this. Okay. So this is W1. And this is equation W2. W2 is C3 sine lambda x plus C4 cosine lambda x plus PA over N0 L x minus PA over N0. And W1 we have solved is equal to C1 sine lambda x plus C2. I changed the B to C2. Cosine lambda x plus A minus L over L times P over N0 x. Okay? So this is for x smaller than A. This is A. It satisfies this equation W1. For x larger than A, smaller than L, it follows this the W curve, 2 curve. Okay? Yeah. So we have 4 coefficients to be determined. Okay? So you have to determine this coefficient after you got a particular solution. Okay? So what the condition we have? We need to find 4 conditions to solve this problem. And we know the condition for W1, the diffraction W1 at 0 equal to 0. And we have W2 at x equal to L, 0. Diffraction at this point, 0. Okay? And what else? We have W1 at A should be equal to W2 function at x equal to A. Okay, the third equation. And the fourth equation will be the slope, because this beam is deformed continuously. So it's assumed under that the slope at A should be same the slope of equation 2 at A. So you have 4 conditions. Then you can solve the C1, C2, C3, C4. Okay? To solve this 4 equations. Okay? You can get and that's easy. For W1, for x equal to 0, 0, 1, 0. So C2 is equal to 0. Okay? So from this, we can find C2 equal to 0 and C1 equal to P0 N0 sine lambda L minus A divided by lambda sine lambda L. C3, C2 0, right? C3 equal to minus P0 over, P0. P0, what's P0? P, no P0. Okay, P over N0 sine lambda x, lambda A cosine lambda L lambda sine lambda L. Okay, and C4 as a P over N0 sine lambda A sine lambda L lambda sine lambda L. Okay? So we solve the 2 equations You just check if the x is over a, you follow this curve. Okay, the diffraction. That's it. Yeah. Okay. So this is W2 at x, and here. So W1 x. Okay. So under actual loading. Yeah. All right. So let's write this equation completely. We have